your title. Solve quadratics or quadratic equations. So let's add that to our title. Solve quadratic equations, okay, by graphing. Now, I'm going to add to this title, because this is not part of the title in your book. You're not going to see the word factoring. We taught you in chapter 9 to figure out how to factor quadratics, okay? We're going to revisit that today, because we're going to show you that by looking at a quadratic, we can solve it by graphing and factoring. Okay, so we're going to actually combine those two things together to do that. Okay? So once you write the title, I don't want you to actually write the examples yet. I want you to write this down next, because this is the most important next information on your homework and on your notes. The key to this lesson is really, where does the parabola intercept or cross the x-axis? Those are your solutions. Those are what we call the x-intercepts, or the solutions of that quadratic equation. All right, so where the parabola crosses or intercepts, that's what we call x-intercepts, the x-axis, are the solutions. So look at my little graphs right here. Again, these are just examples. If I have a parabola here, how many places does my parabola in this first little graph here intercept or cross the x-axis at? How many different places did it cross? 2. So how many solutions will I have? 2. Because right where this and this, wherever that may be, are my solutions of this quadratic equation. Okay? How many solutions do I have for this one? 1. Because how many places do I intercept or cross the x-axis at? 1 place. Where does this, bless you, where does this parabola cross the x-axis at? Does it even cross the x-axis? No, it crosses what axis? Y. But does that count? No. It's only where it crosses the x-axis at. So if my parabola was over here, would that have a solution? No. What if I had, whoops, I'm sorry. I don't mean to do that, because I don't want to mix you up. Okay, so obviously this would be another example of how many solutions would this one be?
2 or 1.
1, right, exactly. Okay, so understand when we say you should be able to look at a parabola and determine the number of solutions by just looking at where does it intercept the x-axis at. Okay? So let's say, for instance, I had... Anyone tell me what those 2 solutions would now be? I know I have 2 solutions, but where does this parabola cross the x-axis at? 1, 2, what? 3. So x equals 3 would be 1 solution. What would the other one be? -2. So if I asked you what the actual solutions were, you would just figure out where does that parabola cross the x-axis? What would those solutions be? I already knew, because I crossed at 2 points, I had 2 solutions, but now I know exactly what they are. X equals 3 and x equals -2. Does that make sense, guys? About figuring out the number of solutions by looking at a parabola. And by looking at it, you also should be able to. So if I said to you guys, for this one, what would the answer to this one be? X equals what? X equals 4. What would the answer to this one be? X equals what? -4. Does that make sense? Okay, so that's going to be part of your homework. It's going to ask you to identify how many solutions you would have, or x-intercepts, and identify what that is by just looking at the graph. All right, that's the introduction to the lesson. But now we're going to get into actually constructing a parabola by ourselves and solving by graphing. Okay, but that's where I added this little factoring piece in. Okay, look at this quadratic. First of all, we understand that it's set equal to what number? 0. So can we factor if it's set equal to 0? We sure can. Let's see if we can revisit how do we solve by factoring. Okay, so what I'm going to do is I'm going to actually find my solutions. I'm going to find where this parabola is going to cross the x-axis at. Okay? All right, so here we go. I'm going to go ahead, now see if we can remember this. Okay? We're going to go ahead and factor this trinomial into 2 binomials. So see if we can remember this. It's been a little while. Okay? We're going to come up with, because a is what? What number is in front of this x squared? 1. So therefore, we can find factors of c, whose sum is b. Wow, good job, guys. Remember that. All right, so can we come up with factors of +8? If it's positive, this is positive, what are my signs to be? Same or opposite?
Same.
Same. Very good. What does the middle term tell me they both have to be?
Subtraction.
Very good, Jack. Awesome, guys. All right, let's come up with 2 factors of 8. Can you guys come up with two factors of 8 whose sum will be negative 6? They both have to be negative factors. Two factors of 8. Negative 2, negative 4. Good, Austin. Negative 2, negative 4. All right, what do we put here and here, guys, to get x squared? X, good. It's all coming back to you, isn't it? What goes here? Does it make a difference? No. 2 goes here, and what would go here? 4. 4. Now, we have what we use the zero product property, which means we set each of these factors equal to what?
0.
Equal to 0. So x minus 2 equals 0, and x minus 4 equal to 0. So we add 2 to both sides here, we get x equals 2 for one solution, and we add 4 to both sides, we get what? X equals 4. So now, guys, we know what we know our parabola is going to be doing, opening up or opening down, class? Opening up, so we know our parabola is opening up, we know that. We know that the parabola is going to cross at what 2 places on my x-axis? 2 and 4. So it's going to be a pretty thin, it's going to be pretty thin, not too wide, okay? But we can't construct our graph yet, can we? What are the 2 things do we need to graph a parabola that we did yesterday, in the day before? What are the 2 really important things we need on a graph? Look over here. What do I have identified right here on this parabola, or on this graph? That thin line we call what? The axis of symmetry and the vertex. Do I have either one of those things right now? So we still got to find those. The nice thing about it is we've already got our 2 solutions. What we need now is the vertex and the axis of symmetry first. All right, so let's go back to our equation right here, a little bit different. But let's go ahead and rewrite this in standard form with y equals x squared minus 6x plus 8. So we're going to write it like this, so we can identify A and B to find our axis of symmetry and then find our vertex, just like we did in 10.2. So we're really doing what we already learned. So what's my A? 1. What's my B? Negative 6. And I really don't need my C, but I still want you to get in the habit of doing it. What's my C? 8. All right. So now we're going to find our axis of symmetry, which is what, class? Remember, x equals the opposite of B all over 2A. Good, okay? Now we're going to go ahead and plug in these 2 values into this equation to find the line that's going to cut my parabola in half. All right, so x equals the opposite of negative 6 all over 2 times 1. What's the opposite of negative 6? 6. What's 2 times 1? 2. So what is my axis of symmetry?
3.
X equals 3. Good. We are 1 step away from having enough to graph this parabola. I already know what my solutions are, but I need to be able to know how to graph it. Okay, we're going to erase this middle part, because we already have this in our notes. But how many solutions we would have depends on where we cross the x-axis at. Okay, all right, here we go. Now we still find our vertex. Our vertex is going to be, what do I already know of my vertex? My x or my y?
X.
X. And what is it?
3.
3. Because this passes through my vertex, so therefore these will always be the same. All right, now we're going to go ahead and plug into my quadratic my x and solve for my y. So y equals 3 squared minus 6 times what? 3 plus what?
8.
Plus 8. So y equals 3 squared is 9 minus 6 times 3 is 18 plus 8. Okay? Work from left to right. 9 minus 18 is negative 9 plus 8. What's negative 9 plus 8? Negative 1. Class, tell me this too. What would this negative 1 represent? Would this be a max or a min value? Min value. Exactly. Good job. Because we understand that because the parabola is opening up, our vertex would be a min. So then the y-coordinate of our vertex would be our min value. Very good. Just a little reminder as we're going through that. So we have our vertex. We have our solutions where the parabola is crossing the x-axis at. And we have our axis symmetry. Do we have enough to construct a parabola now? We sure do. All right, let's go ahead and construct it over here on our coordinate plane. Okay, so I'm going to go ahead and start with my vertex. over 3, 1, so here's my origin, 1, 2, 3, and plot a, and I'm sorry, not plot a point, sorry, 1, 2, 3, and down 1. So here's our vertex. We already know that parabola is going to be opening up because our A was positive. Alright, I'm going to plot, I'm going to draw my axis symmetry, which is going to pass through. So my vertex is 3, negative 1. My axis symmetry is x equals 3, so this is going to cut through, go through my vertex. X equals 3, label both those, the axis symmetry and the vertex, always label those two things. And then here's my two solutions, 2 and 4. I go over to 2 on my x-axis, plot a point, and I go over to 4 on my, and plot a point, and there is my parabola. And how many points did my parabola cross the x-axis at? How many? 2, so how many solutions do I have? 2. And what are they? 2 and 4. Does that make sense, class? So what do we start with? We start by making sure that our equation is set equal to 0, and we factor first. Yep, we factor that quadratic first, find our 2 solutions, or sometimes in that case, 1 solution, or what?
No solution.
Or no solutions, right. Okay, then we go back, find our axis of symmetry. Okay, then we would use that value just to find our x coordinate of our vertex, plug our x in and solve for our y. Okay, and then again, making sure that we understand the parabola, which way it should be going. Is it should be opening up or down? We obviously look at our A. Whatever our A is, tells us whether it opens up or down. Okay? Does that make sense, class? Yes, Tim?
I'm kind of confused on how you draw the parabola. So,
How I draw the parabola?
yeah, like, I might have